So let's continue this session on disaster mitigation monitoring and NRENs. Um, it's a pleasure to have Casper with us. Hello there, and very good morning.
Good morning, everyone. Yeah, and very good morning here from Rome.
Yeah, we can hear you perfectly. Thank you. So in the first session, we had presentation from Mr. Bayani Lara, wherein he introduced our agency as well as some of the activities related to disaster mitigation monitoring, as well as the establishment of our NREN called Preginet. After that, I think you were able to catch a glimpse of it. And then after that, we had DDG Dennis Villorente, and then he gave some updates about what the Philippine Space Agency is doing currently, and he also introduced the CopPhil initiative in the country. So for this session, let's just follow up on that discussion. Probably we won't take up the whole 1.5 hours of this session. I know you have lots of experience in working with Copernicus data. Probably you could share some of the more important realizations or activities, significant activities you've done so far, and how you would bring that in our own initiative back in the Philippines. Thank you, Casper.
Okay, thank you very much. Um, yeah, so I did manage to catch a little glimpse of the presentations before, but I might be repeating some things. But um, I'll go ahead. So for Copernicus in the Philippines, I won't go through the whole introduction since you had that in the previous session, but we are developing three services on top of the mirror side in the Philippines. Um, one of them being the ground motion monitoring service. Um, this one is very well positioned for disaster mitigation monitoring. This is continuous monitoring using INSAR from the Sentinel-1 satellites. I'm very happy that I can say satellites again instead of just one. That produces continuous monitoring of the movement of the ground in the Philippines. This is especially useful for early warnings in case of unstable grounds, subsidence. It could be landslide monitoring too. And this is already set up. We already have the results coming in from this. This is being continuously improved, but this is running for the Manila area and also for Eastern Mindanao at the moment. Um, besides that, we don't have a specific flood monitoring service in the CopPhil program. However, we do have a lot of complementary services that can be tailored and adjusted to disaster use cases. So one of these services we have is the land cover monitoring service, which is providing land cover maps for the Philippines at a very steady pace at annual maps currently, but it can produce every second week. Or when we have cloud-free imagery, we can update these maps as they come in. These can also be used for monitoring. However, the current service uses the Sentinel-2 satellites, which is an optical satellite, which is in cases of heavy cloud cover, not super beneficial for flood mapping. But since the mirror site is also ingesting all of the Sentinel-1 data coming in from the Copernicus program, we can augment these services to add things like flood monitoring too. Um, all of these products that we're producing can be ingested into larger systems, such as for early warning systems. And it can also be used in determining the impact that disaster might have. or figuring out the impact post-disasters as well. Um, this would be using both the land cover products, but we also have the forest monitoring and the agricultural monitoring service too, which monitors crop types and crop land in the Philippines. So we can determine the impact of disaster events on these industries. There's a continuous monitoring of forest disturbance in the areas of the Philippines. So this would be beneficial in the case of forest fires, or it could be heavy storms as well that have an impact on the forest themselves. So this is just a brief overview of how some of these services could be used in disaster mitigation and monitoring efforts. All the data from the mirror site is already in the Philippines, and the mirror site itself is placed next to the high-performance computers of both PhilSA and the Department of Science and Technology in the Philippines, meaning that it is readily available almost as soon as we get it here in Europe. Through the, I'm not an expert on research networks, so apologies for my ignorance on this. But it is, we're going through the GN network for this currently. When the mirror site was in Warsaw, it's been transferred to Manila. It's currently being installed, so it's not up and running at the moment. But our plan is to go through the research networks again once it's up and running. Yeah, I think that was it for my introduction.
All right.
Yeah.
Uh, Thank you, Casper, for those updates. I heard from Dr. Ariel Blanco that the actual servers are now in the Philippines. They are actually at our customs, I guess, awaiting release, and soon they will be installed in one of the Science Ministry's data centers. Anyway, so you've mentioned some particular areas, for example, for ground motion monitoring. You've started work in the Manila area, and if I remember correctly, Eastern Mindanao, that's the southern part of the Philippines. How do you choose which areas to focus on, to process on?
Okay. So all of these areas of interest for CopPhil have been chosen together with the stakeholders in the Philippines. So we're just one of the three implementing partners in CopPhil. So it's ASA, PhilSA, and the Department of Science and Technology. And we're really developing this together. And we've had consultations with the mandated agencies in charge of the um, in charge of the products from the services. So in the case of ground motion monitoring, uh, like the Fivolts and Pagasa are very interested in this service. And we've defined together with them what the areas of interest could be. So in Mindanao, you have volcanic activity, and in north and eastern Manila, you have land subsidence happening at a very rapid pace. So these are high interest areas.
All right. For those who might be interested in processing images or applying some algorithms, um, are these technologies based on the research that were done, for example, in Europe, or are these, let's say, algorithms or systems that were developed locally in the Philippines?
So these are global algorithms, if you like, that are being tailored specifically for the Philippine use case um, by our contractors. So the technologies behind them are all open source. So all of it is, well, the code is not openly available yet, but it will be in a few weeks. So all the code will be available so anyone can expect them and reuse it as they see fit. The technologies themselves, mostly for the Sentinel-2 derived products, are pretty tried and true algorithms. There's most of them are based on random forest approaches. For INSAR processing, it's a bit more complex. This is being done by a company called Tre Altamira, which has some very complex INSAR processing algorithms. However, they are not using, they are they are validating the approach that we are taking in our open source approach. So the entire INSAR processing toolchain is also open source and openly available. Um, and these are then, some of them are trained on a global data set and then fine-tuned on the local use case of the Philippines, and some of them are trained solely on Philippine data.
All right, thank you so much. So I guess at this point, I'll open the floor for some question for Dr. Casper. If anyone has particular question.
No. uh, Question is always the same. It's just when is your plan to expand to ASEAN, the whole ASEAN, other country?
So thank you very much. So we are currently in the process of doing a pilot regionalization of CopPhil, where we're looking to not expand to all of ASEAN, but we are going to start with two countries to expand the services and the ideas of CopPhil. And then hopefully based on that and our experience from that, we will be able to expand this to all of ASEAN afterwards. But we are going to do this in phases. The pilot regionalization starts this year, uh, and I imagine the next phase will be in 2026.
I guess that's a secret for now. Yeah, Chai is interested to know which are those two countries. I said, "Well, probably it's a secret for now," and then we'll know sooner or later. All right. So Casper, how about in terms of capacitating our end users and let's say local agencies because they are the one who will be processing, interpreting, and even disseminating the results. Can you share some of the activities being done currently?
So, uh, yes, thank you very much. This is a very, very get the feedback and even get change.
Sorry, Dr. Casper, I think we've lost you for the past couple of minutes. Can you repeat your answer, please? Sorry. Oh, he froze again. All right, so let's just wait.
Hi, everyone, again.
There, Dr. Casper. Thank you.
Hi, sorry, my internet is apparently not great.
Yeah, we lost you the past couple of minutes.
Okay. The last thing I heard was the question on capacity building.
Yes, yes, that's right.
Okay. So capacity building and it's an extremely important pillar of CopPhil. We are co-developing all the services together with the mandated agencies that are in charge of these services. And we are doing this through a series of sprints where we are developing a prototype, presenting it to the stakeholders, gathering feedback, and then doing a new loop. And we have 9 of these planned, and the last ones will be just before summer, I believe. And besides this, we then have training events for not just the technical people, but also people who might not be users of Earth observation currently, but would like to be in the future. We've had 2, maybe the third one was held last week. I'm not exactly sure, but we've had 2 or 3 of these training events so far, and they are very well visited. The last one we had on land cover had more than 100 participants. And these are people from the mandated agencies who want to use the land cover services. The training is planned in a bit like, well, we build on top of each other. So the beginning is a basic introduction to Earth observation. What can you use a land cover map for? And then it goes more and more technical as the training progresses. And then at the height or at the end of the summer this year, there will be a graduation ceremony, if you like, in connection with the Philippine Space Week in August.
All right, that's awesome. Okay, so thank you, Dr. Casper, for your time. I know it's very, very early morning there in Rome, but we sincerely appreciate your presence here in our session. Thank you so much.
Thank you very much.
All right, so from Dr. Casper, let's move on to a bit to Andrew here at my back, just to hear from him because they've been working with Copernicus in Australia, right? For the past couple of years, maybe he could share what they've learned, how the impacts actually of this initiative, as well as the challenges they've surmounted, so we could learn a bit from them as we do a similar project back in the country. Please, Andrew.
Sorry, I haven't prepared a slide deck for this, but I thought I'll just kind of talk through some of our Sentinel journey. We've been pulling the Sentinel data in for around 13 years, so we have about a 12-year collection which occupies 5 petabytes of data. Our area of interest runs from the western border of Pakistan, across the southern border of China, out into the Pacific, covering Niue. That was about 36% of the Earth's surface. We've recently expanded our area of interest to cover all of Antarctica as well. There are a number of subsequent programs that operate on this data. NCI is the National Computational Infrastructure. We're one of the 2 high-performance computing centres in Australia. We operate the Copernicus Hub on behalf of Geoscience Australia, which is the government agency, which also is the space agency, holds the space agency under their ministerial direction. The tools we've used for the last 12 years were all pretty much homegrown. Over that amount of time, we've tuned and optimized the data flows as we move forward. The European Space Agency around 3 years ago announced that the existing download system would be deprecated for a new system called DHOS, or DOOS as you Europeans call it. We're about 2 weeks away from going live with the implementation of that. And the European Space Agency then made another change to move to a new Copernicus hub system. So we've been one of the first participants to actually have that operational. It's taken about 18 months of work with our colleagues at the European Space Agency to do a number of things in terms of optimizing the software, in particular doing a lot of network tuning. Australia and New Zealand are the furthest countries away of anywhere on the internet. So to achieve a performant data flow, there needs to be network tuning in all elements of the path. Our Philippine colleagues will benefit from the work we've done across all of the Asian research and education networks, in particular NREN, and then the connection running up to Giant through London. Some of the challenges we've had on the implementation earlier this year were that the performance was not meeting our normal 4-hour window that we would pull all of the data from Europe and make it available to Australia. Over the last 4 weeks, we've seen around 1,000% increase in data flow performance as more work has been done on tuning the background hub software. The Australian government has basically paid an organisation called Gale Space Systems, who run the Central Copernicus Node 2 in Europe. They've been developing the software. It's been made available as an open source. So that provides all of the front-end interface to access the new data formats that are coming out. We have coverage of all of the Sentinel satellites, so Sentinel-1 through Sentinel-5P. Each of the satellites has a different spectral frequency that they're able to use. Like the Philippines, we're using this data for a number of downstream applications. So the operational cost that Geoscience Australia pays is around $1 million a year Australian. From that, we generate $5 billion of gross domestic product input from that data. Our projections are showing that this will increase to a $30 billion Australian dollar GDP impact by 2030. So the federal government funds this. It's then passed down to a number of state government agencies. In Western Australia, it's being used for agricultural management, looking at some of the mining capabilities that we've got, also looking at shifts coming adrift from their anchors and moving around the coastline. Our colleagues in Queensland use the data with a machine learning system to track land clearing. That's something which is very sensitive to Australia, is the illegal clearing of forests. So we now are able to dispatch the appropriate authorities within 24 hours of somebody cutting down a tree illegally in the state. In New South Wales, the data is being used for management of forestry, and also combined with a lot of LiDAR data that the state agency is producing. This gives you a ground-up view in 3 dimensions with the data overlaid from Copernicus, looking at climatic conditions, how the weather's changing, climate forecasting. There are a number of articles in terms of the flood management that Copernicus is involved with. If you would like to search the ABC News site, there was an article last week looking at floods impacting the Barrier Reef. We also use the data for monitoring incoming illegal vessels and illegal fishing in our waters. So the products are all publicly available. The source code for everything but the administration interface is in public domain and open source. My colleagues from Geoscience Australia are visiting Europe this week to negotiate opening the admin portal, which basically is the control front end. So we're making very good progress. We went into beta release on Friday with the state government agencies with a complete switchover from the old system to the new. Some of the complications of the new system: the old system used a lot of structural metadata in the directory structure, which allowed you to drill down to a particular product. That's become a lot more complex in the way that the new system actually stores the data. But we have come up with a method of providing some kind of translation between the older metadata structures and the newer metadata structures. The data is also being used on a number of projects. Digital Earth Australia combines satellite imaging from Landsat, IMSA, Copernicus, as well as the marine sonar buoys that we have around, also looking at wave level wave level changes. There's a Digital Earth Africa, which has been quite successful in doing the same sort of things in Africa. And the department announced that we would be moving on with Digital Earth Antarctica. So last week we increased our coverage area to include all of Antarctica as well, which brings us up to around 46% of the Earth's surface. We expect the data to grow to about 30 petabytes by 2030. And as I said, we hold around 20 to 30 years of combined satellite data over all of the satellite systems that we can see. All of that is publicly available and accessible. So if you do run into any issues accessing any of this data, please reach out to me. I'm happy to either resolve it or pass it to the appropriate government agency if it's a political level issue. But yeah, we found the performance of the Gale space system, GSS, has been very good. The acceptance has been good by our downstream users. One of the key features that brings is, and this can also be seen as a slight downside, based on European regulations, we now require people to register. Now this will allow us to provide a differentiated level of service. Our colleagues in the Philippines pulled about 1.5 petabytes of our archive. So that was like a fairly large download capability for us. We pull around 15 to 20 terabytes per day of additional data off Sentinel systems. So we've tuned the network. That tune is available on the ESA website. But once again, I'll put my network engineer hat on. If you need any assistance with network tuning or operations, also please reach out to us. Our colleagues at ARNet and our colleagues in Giant have been really good at helping out with this, so we can connect you to the right people and make things easier if the performance that you're getting for your end users is not up to the level that you need for doing the exploration. So there's Copernicus will be launching new satellites going forward. Sentinel-2C was launched about 3 months ago and went operational. Sentinel-1A was having problems. That's been moved into a new orbital position and brought back online. And there are additional Sentinel-5 satellites planned for this year. So it's basically scheduled on Ariane launch dates out of French Guiana. If anyone's got any questions, I've been intimately involved in this project for about 12 years now, and I wrote the original code at NCI. So it's actually good to retire some of my old work and move to something which is a bit more standard.
All right. Thank you so much, Andrew. And it's really nice to hear that. Okay. Oop.
Sorry. Yeah, all good. I'm fine. It's okay.
All right. Let me pull up a chair for you.
Yeah, perfect. Thank you. Should I have my stick? Sit down for a second.
Sure.
Sit. Stand first.
Yeah, all good.
Okay. All right. It seems that we have a lot to learn from your years of experience in working with Copernicus. More is coming. How, with the lots of data coming in, lots to be processed, how is the network in the computing infrastructure being pushed? Is it being pushed to the limits, or do you have much leeway to do more for Copernicus? How is it?
The current system uses a 10 gig network connection. We've got two 100 gig network connections coming in. Current utilization is around 3 gigabits per second. So we've got more room to expand onto that. We'll also be migrating some of our data transfer nodes, which we use to pull the data in, to be cloud-based systems running on our NREN cloud. So that is all 100 gig networking. It gives us a lot of extra scope to expand out.
If the computation you have problem, let the cloud working group know. Eric left already, and then you can go and share and work on that. Like for Taiwan Grid, they allow you to just use the system. Yeah, just get the account and you ask Eric, and you can access and do it.
Okay.
You don't have to build it.
Yeah, and if I understand correctly, you don't delete anything.
That's a big problem.
You just collect and build a larger repository.
We're just going to market for a new increased file system. So we're pretty much at capacity on the one that the Copernicus data is on, but the new file system should be in the range of 30 to 40 petabytes, so that'll give us a lot of extra breathing room on Copernicus data. But we're looking at around 30 petabytes by 2030.
Now, on the side, just a side question, have you had any issue regarding cybersecurity or, malicious attempts to, I don't know, access the data for whatever reason?
Not directly. One of the biggest users we saw, there was an errant script which was trying to just keep downloading the same product time after time. So I think we reached out to Dennis and said, there seems to be something wrong. He had that fixed in a couple of days, but that certainly generated a use spike that we saw. Other than that, the cybersecurity on it's quite tight. But it is all public access data, so it's there for everyone to use. So yeah, just let us know if there are performance issues, and we can certainly work on that. But the hub is available for all people in Asia to use.
And then I would also imagine, since there are many applications or algorithms being developed, you've also collaborated with many universities in Australia.
The collaborations are typically through the state government departments. So in Australia, the Australian National University is the only federally funded university. So the state governments have engaged their local universities to do things like machine learning and AI interpretation, to develop new sensor capability as well, like we saw that you were doing. We're also doing a lot of work with microsatellites, so that seems to be a big area of interest for the students. And we've had some successful launches on Starlink to get microsatellites into orbit. But there are, as you saw, there's a kind of constellation of satellites on different spectral frequencies, which give you a whole range of data. One of the most interesting things that we saw was the earthquake in Tonga, or the volcanic eruption in Tonga. Fortunately, one of the satellites was directly overhead, so we saw all of the gas cloud emerging out of the ocean, and that has provided a lot of data in terms of those undersea ocean volcanoes that we hadn't seen as a massive threat before. And there's been, I think, around 10 or 20 more of that magnitude discovered as part of looking at the synthetic aperture radar.
Aside from the data you get from Copernicus, Australia has its own set of sovereign satellites?
We have, we mainly use Himawari because that gives us coverage for weather systems, so that is actually fed into the Bureau of Meteorology weather forecasting system.
Himawari 9?
Yeah. We also have Landsat. We've collected data off that for the last 20 years. We're currently working on the Landsat Next project, and that will probably also be integrated into our Copernicus hub in some way. We've also got a transectional data analysis system that can drill down through multiple years of data. So if you're looking at vegetation changes or coverage, that's something we've been using for managing the result of bushfires. Yes. So looking at how the forest starts growing back, what the impact to animals and plants is in those areas. So, as Australia is fairly prone to natural disasters. So, we're able to use as much of the data as we can and then quickly pivot to responding to natural disaster events.
Right, right. How about typical question for those handling lots of data, satellite images? What's the Australia's policy, let's say, on keeping privacy and confidentiality of some, areas in Australia?
There is no censorship. We don't provide.
No
We
censorship.
don't do any censorship of the data downstream. So, all of the data coming off these publicly accessible satellites is available. The defence sensitivity, I think, is quite low. And our Defence Department also uses it for some of their planning. So, from our point of view, it's maintaining a highly available operational service with the minimum possible delay of data reception from downlink from the satellites.
So which encourages you to further upgrade and develop more downstream services, I guess, with all the data that you receive. All right. Again, would our audience have any other question?
No, I just saying that to be a member of CEOS, you don't need to have a satellite. See, you don't need to. But most of the people thinking to become a member of CEOS, you need to have a satellite. The first started with Thailand. I did it. So yeah, you don't need that because they argue all the time that you need to have a satellite to become a member of CEOS. No need. You just think. You use this is very good decision that use money for something else that lacking, like
Australia doesn't have to launch lots of
no
satellites
need.
because they're already benefiting from the
Yeah, so
constellation of
many
satellites
already. So you use that for the application for the services.
Yeah, services, upgrading networks, etc., keeping all things
Yeah, that's
together.
what I'm saying. Feels
Yeah.
like they have to do more on the services,
Yes.
which is needed, because with the Copernicus emergency and the international charter,
Yeah.
they need those to
Yeah.
do the products as soon as possible.
Yeah.
So if you put all most of the money to the services, which is can increase the response time,
Right.
would be more benefit than just distributing data.
Yeah.
Yeah, that
It-
work. That work.
From what Andrew mentioned, the impact on GDP, they've already benefited so much more
without
from what they've invested, right? So we are yet to get there. Of course, we have to leverage all the data that we have. All right. So any other questions from our dear audience now? All right, none. If none, then again, thank you, Andrew, for your time. And we also have to thank Dr. Casper earlier. I guess we finished early, so thank you again. This is actually the first workshop hosted by us, the MWG group, especially on this session. Probably the next APAN, we can continue to do more. See you around and enjoy the rest of your stay here in Yokohama. Thank you so much.
Hey, don't forget that they have to stop by another session, the disaster.
Yeah, of course, the MWG on
Share,
Wednesday. Please drop by our session on Wednesday morning. Thank you so much.
And perhaps other agriculture too. Don't forget to stop by the agriculture working group and then open and sharing. Yeah, we all talk about this thing and then we try to do the application in the agriculture. So.
All right, thank you so much and see you around. Thank you.
I didn't bring mine. It's just like, no use for that. Can use friend. Bring book. But you need to monitor all the time. That's the problem.
Then Dennis Villorente. He was supposed to come here and present physically, but he had some problems with his travel documents. He'll be leaving this afternoon, arriving later this evening, but probably we can accommodate him in our session on Wednesday,
Okay.
just to make his presence more felt here.
Yeah. Yeah, why secret?